Today we're doing the last section of section 5.5 of solving trig equations. We are going to be using our formula sheet for chapter 5, so please locate that. Again, we're going to be having a test shortly after this lesson, so it's important that you have those formulas handy. So for our first example, we're going to have sine of 2x plus pi over 4 plus sine of 2x minus pi over 4. And this is equal to 1. So looking at your formula sheet, we're going to have to use the top part where it says the sum and difference formulas. So we're going to be using the sine of alpha plus beta formula and the sine of alpha minus beta. So this is our alpha, this is our beta. This is our alpha and this is our beta. So again, if you want to pause the video so you can look at the formula and try this on your own, I recommend you doing that. So for the first one, I need to use this formula of sine of alpha plus beta. And the formula says sine of alpha, so I'd have sine of 2x. And then it says times cosine beta, so cosine of pi over 4 plus cosine alpha sine of beta. So both these terms just replace the first formula. So now I need to figure out what's going to replace this formula right here. So I'm now using the sine of alpha minus beta. I'm just going to write it on the second line. So that formula says sine of alpha cosine beta minus cosine alpha sine of beta. And when you're looking at this, you should notice that these two terms, one is positive and one is negative. So this term here and that term are exactly the same. It's just one's positive, one's negative. So they're going to cancel out. So now these terms are like terms, so I can say I have two of these terms. Okay. And this is equal to 1. And now I need to kind of clean this up a bit. This right here, I know cosine of pi over 4 is root 2 over 2. So I now have 2 sine of 2x times root 2 over 2. And this is like a 2 over 1, this is like it's over 1. So this 2 over 1, this 2 in the numerator, can cancel with this 2 in the denominator. So I'm going to switch screens so I can proceed from there. So now I'm at sine of 2x times the square root of 2 is equal to 1. And if I want to get sine by itself, I would divide both sides by root 2. So now I'm at sine of 2x equals 1 over root 2. And we know we can't leave our answer like that, so we'd have to rationalize. So sine of root 2 over 2. And now, oops, I forgot to write the angle. So sine of 2x equals root 2 over 2. And now I need to figure out what my equation is going to be so that I know what to solve. So my angle, sine is going to be a positive root 2 over 2 when it's pi over 4 and when it's 3 pi over 4. So we're going to set this up. I'm going to take what's here, 2x, and set this equal to pi over 4 plus 2n pi. And to solve for x, I would divide by 2 to every term. For pi over 4 divided by 2 over 1, I keep change flip. So x will equal pi over 8 plus n pi. And for my second equation, there's 1. 2x equals 3 pi over 4 plus 2n pi. And again, I have to divide every term by 2. So I'll get x equals, again, keep change flip for this fraction. So I'll get 3 pi over 8 plus n pi. So here are our two equations that I need to use. If I need to find all my answers along the interval of 0 to 2 pi, this is where we're going to plug in values for n. So I'm going to switch screens again. So that x equals pi over 8 plus n pi, and x equals 3 pi over 8 plus n pi. So I'm going to check my scenarios. When my denominator is 8, I know 2 pi is the same as saying 16 pi over 8. So 16 pi over 8 is our cutoff that we're looking for. So I know when I plug in 0 for n, I'm going to get pi over 8 and 3 pi over 8. Then I'm going to plug in 1, and I know I can change this to be an 8 pi over 8 so that I have common denominators. So if I plug in a 1, I'll get 8 pi over 8 plus 1 pi over 8, so I'll get a 9 pi over 8. And on the second one, 8 pi over 8 plus 3 pi over 8 will be 11 pi over 8. Alright, so we keep going, so n equals 2. When I plug in 2, I get 16 pi over 8 plus 1 pi over 8 is 17 pi over 8. So I know right here that I'm too big because I'm over this cutoff, so I stop. And these are my final 4 answers. So we're going to do one more example for this evening. So the last example for today is cosine of x, sorry, actually sine of x times cosine of x is equal to 1/2. Again, we're assuming that we're solving this with the interval of 0 to 2 pi. So when I look at this problem, I can't FOIL, I can't factor. I have 2 different trig functions, but I don't know what to set them equal to because it's not equal to 0, so I can't split it up that way. So we're going to have to kind of get creative with our identities. So my first thing that I'm going to do is actually multiply both sides by 2. And when I do that, I get 2 sine of x cosine of x equal to 1. Now I want you to look at your formula sheet again that you should have out from chapter 5. And I want you to look around until you see where it says 2 sine of x cosine of x. So this is actually one of our double angle formulas. If you look at that section, you'll see 2 sine of x cosine of x. So that can be replaced with sine of 2x. And now by doing that, I was able to get this in terms of one trig function, so now I can proceed from here. So the angle that I'm working with, so remember sine is the y part of the coordinate. So 0, 1 is our coordinate, and that comes from a pi over 2. And the period for sine is 2 pi. And to get x by itself, I divide by 2 to every term. Here, I'm going to keep change flip. So I'll get pi over 4 plus pi n. And now I check my scenarios. So when n equals 0, I get pi over 4. When n equals 1, I can go over here and make this be a 4 pi over 4 so that I have those common denominators. So when n equals 1, I'll get 5 pi over 4. And when n equals 2, the moment I plug 2 in, notice I'll get 8 pi over 4, and then I'm adding another 1 pi, so I'm at 9 pi over 4 But if I'm going back up here to my cutoff, if I get common denominators, that would be an 8 pi over 4. So I can't go any higher than 8 pi over 4. So that answer is too large. So these are our final answers. All right, that's all for today.